Good morning, everyone. Today we are going to discuss about the overview of characteristics of the wireless channel. This comes under Unit 1 in the introduction of ad hoc networks. So, what are the transmission impediments? So, the transmission impediments are the path loss, interference, and blockage. These three bulletins are transmission impediments. So the factors restrict the transmission is the range, data rate, and the reliability of the wireless transmission. In detail, we'll see in the further slides. So the transmitted signal as a direct path component between the transmitter and the receiver. Between the transmitter and receiver, there is a direct path, that is path between the transmitter and the receiver. The other components of the transmitted signal are multipath. So direct path and multipath component. In the multipath, it may be reflected, diffracted, scattered signal. The signal from source to destination, it will reflect or diffract and scattered before reaching the receiver. So the receiver shifted in the amplitude, frequency, and phase with respect to the direct path component. So there are two path communications between the our transmitter and receiver is direct path and multipath transmission. So what are the various characteristics of wireless channel? So the characteristics belongs to path loss, fading, interference, and Doppler shift. So the key constraints of these characteristics, the two theorems are used to constraint for these characteristics, Nyquist and Shannon's theorem. These are the ability to transmit information and different data rates, the Shannon's theorem. So next, what is path loss? So path loss. So the path loss can be expressed as the ratio of power of the transmitted signal to the power of the same signal received by the receiver on the given path. So between transmitted and received signal, the ratio of the transmitted and received signal is a path signal, path loss. So the path loss having two or three propagation models. So first one is the free space propagation model. The free space propagation model is the simplest path loss model, in which there is a direct path between the transmitter and receiver. So already we have seen about the direct path and multipath. Direct path is direct connection between transmitter and receiver. So multipath means it will be the signal may be refract or diffract from the intrusion or from the buildings, like that. So here the free space propagation model is the direct path signal between the transmitter and receiver with no atmospheric attenuation or multipath component. So it is given by PR equal to PT into lambda divided by 4 pi d whole square. So here the PT and PR are the transmitted power and the received power. The GT and GR are the transmitted and receiver antenna gains. So D is the distance between the transmitter and receiver, and where lambda equal to C by F, that is the wavelength of the signal. So next one is the two-ray model or the two-path model. So the two-ray model or two-path model is the two paths, that is one a line of sight path, that is direct path, and another one path through, which is reflected or refracted or scattered wave received by the receiver. So the expression is given as PR equal to the received power, given as PR equal to PT GT GR into HT HR divided by D square whole power square. So already seen PT, what is PT, GT and GR, that is transmitted power PT, GT and GR are the antenna gains and transmitter and receiver antenna gains. And here the additional terms are the HT, HR. That is HT, it's a transmitter height, and HR is the receiver height respectively. So where D is the distance between the transmitter and the receiver. This is a two-ray model or the two-path model. So next, isotropic antenna. For isotropic antennas, the antenna means the power of the transmitter signal is same in all directions. So that is isotropic antenna. The received power of the signal is given by PR equal to PT GT GR divided by into lambda divided by 4 pi whole square into 1 divided by d power tau. So tau is the propagation coefficient that varies between 2 and 5. That is 2 is free space propagation and 5 is the strong attenuation. So next is fading. So what is fading? Fading refers to the fluctuation in signal strength when received at the receiver. So there is if any fluctuations in the signal received at the transmitter is known as the fading. The fading can be classified into two, that is fast fading and slow fading. Whereas fast fading occurred in the small scale fading, and the slow fading occurred in the large scale fading. Next, fast fading. What is fast fading? The fast fading refers to the rapid fluctuation in the amplitude, phase, or multipath delays of the received signal due to the interference between multiple versions of the same transmitted signal arriving at the receiver at slightly different times. So we'll having a delayed amplitude or phase. Fluctuations are known as the fading. The time between the reception of the first version of the signal and the last echoed signal is called the delay spread. So initially there are two paths. One is direct path and the multipath. Where direct path received signals are something correct time, wherein the second, that is multipath signal. So multipath signal may be reflected, refracted like that signal. So it can be delayed such time. So this time between the reception of first version of signal is maybe of direct path, and the second, the last echoed signal may be reflector, refractor wave. So multipath propagation of the transmitted signal, which causes fast fading because of reflection, diffraction, and scattering. These are the propagation mechanisms. Reflection, diffraction, and scattering are the propagation mechanisms. So slow fading. So slow fading occurs when objects that partially absorb the transmissions lie between the transmitter and receiver. So observe the transmission is known as the slow fading. Slow fading is so called because the duration of the fade may last of multiple seconds or minutes. So this, we can call it as a shadow fading. So slow fading may occur when the receiver is inside a building and the radio wave must pass through the walls of a building, or when the receiver is temporarily shielded from the transmitter by a building. So next, interference. So what are the interference occurred? So wireless transmission have to counter interference from a wide variety of sources. Two main forms of interference are adjacent channel interference and co-channel interference. So first one, adjacent channel interference. What is adjacent channel interference? The adjacent channel interference case, the signals is nearby frequencies have components outside their allocated ranges. So and these components may interfere with ongoing transmissions in the adjacent frequencies. So if you consider a sinusoidal waveform, there is overlapping between the peaks. Is known as the adjacent channel interference. It will cross over allocated spectrum range and overlapping to the other signals. So it can be avoided by carefully introducing guard bands between the allocated frequency ranges. So this adjacent channel interference may be avoided by introducing guard bands between the frequency ranges of the transmitted signal. So Next, co-channel interference. So, co-channel interference. What is co-channel interference? So, co-channel interference sometimes also referred as a narrowband interference. So, due to nearby systems. So, if you say AM, FM broadcast using the same transmission frequency. So, if the same transmission frequency has co-channel interference, it can be minimized by using methods of multi-user reduction mechanisms, directional antennas, dynamic channel allocation. So, by using these mechanisms, we can minimize this co-channel interference. So, next, intersymbol interference. So, intersymbol interference is also another type of interference where the distortion in the received signal. So, the distortion in the received signal is caused by the temporal spreading or consistent overlapping of individual pulses in the signal. When the temporal spreading of individual pulses, maybe delay spread, symbol reduction time, the receiver becomes unable to reliably distinguish between changes of state in the signal. That is, a bit pattern interpreted by the receiver is not as same with the sender. So these are the inter-symbol interference. So the adaptive equalization is commonly used technique for combating inter-symbol interference. We can use adaptive equalization technique to overcome this inter-symbol interference. The main principle behind adaptive equalization is the estimation of the channel pulse response to periodically transmitted well-known bit patterns known as training sequences. So the estimation of channel pulse periodically transmitted well. That is the main concept of eradicating this interference. Whereas adaptive equalization commonly used to overcome this inter-symbol interference. So that's all about this topic. Thank you.